Okay, so this is number 3. This problem is actually like what we've been doing in chapter 20, so a previous chapter where there is a claim. And the claim is that 7% of the components are defective, the computer components. And so that sets us so that we don't have two proportions that we are defining. We are only defining one. And we are going to determine the proportion of this particular computer component that are defective. So we're going to take one sample and attempt to determine the entire proportion that is defective. All right, so that makes our null hypothesis that P is 0.07, found from the here. And then we are wondering if there is significantly more defective, so that's P is greater than 0.07. So that's your perimeter, your hypothesis statements. Random is stated. We have just one proportion, so we are doing this one sample of 175 is less than 10% of all of these types of computer components. Large enough, the sample size of 175 times the p hat, or the claim, 0.07, is 12.25, greater than or equal to 10, and the other part of it is greater than or equal to 10, so the normal model applies. This is a one proportion Z test. Now, then we go to the work, and what we have here is the sample that was achieved was 18 out of 175. So that sample was 0.103. And so that is what we are comparing to the 0.07. Now, you actually can do this in the calculator, but I find it just as easy to go ahead and compute this z-score yourself. So the z-score of, or the p hat of 0.103 minus the claim of 0.07. Your standard deviation comes from the formula of the square root of p times 1 minus p over n. So here's the standard deviation. That is a z-score of 1.71. Then I norm CDF from 1.71 to 99. And that's how I get a p-value of 0.0436. So with a p-value of 0.036, it is actually barely lower than alpha, but it is lower than alpha. So since this p-value is low, the null hypothesis has to go, and we reject the null. So what we are rejecting this claim that the proportion of defective parts is 0.07. And we are determining that, indeed, it is greater than 0.07. So that's what we say in our conclusion. Here we say, since the p-value is less than alpha, I reject that the proportion of computer components that are defective is 0.07, and I have evidence to suggest that there actually is significantly more than 7% defective chips.